Hello, dear student. Welcome to Strive 365. So, 1 year newspaper and current affair analysis. So, dear student, we have already covered your polity, international relation, internal security, and today we are going to see about science and technology. And this current affair is very much important for UPSC, OPSC, and other state PCS examination like BPSC and UPPCS. So, before discussing about science and tech, so let me give some brief detail about what we are mainly intending in this class. So basically, we are going to see each and every current affair, and I am going to link each and every current affair with what possible question they have been asking in the previous year. देखो मैंने खुद ही यूपीएससी को बहुत बार क्लियर किए दैट टू ह्यूज मार्जिन कट ऑफ बिकॉज I am having that experience of how I am linking each and every current affair with possible questions. So please focus on that and watch the video till the end. And to get this PDF, you can join our Strive IAS Telegram channel. From there, you will get the PDF. ठीक है? चलिए शुरू करते हैं. So first topic that today we are going to discuss is about space program of India. So why it is in news? Because Lok Sabha discussed the critical role of space program for Viksit Bharat. अभी क्या हुआ था लोकसभा में एक डिस्कशन हुआ था कि व्हाट इज द इंपोर्टेंस ऑफ आवर स्पेस प्रोग्राम टू इंश्योर ए डेवलप्ड इंडिया बाय 2047. तो अगर हमें डेवलप्ड इंडिया बनाना है तो स्पेस प्रोग्राम का क्या रोल रहेगा. So more about this news. So highlight that because this discussion held after our astronaut Subhanshu Suklaji visited International Space Station trips using Axiom 4 mission and symbolize India as a Vishwabandhu Bharat. So I think you already know that our the Air Force pilot Subhanshu Suklaji visited to International Space Station under the mission Axiom 4 mission. So this can be a very good question. So they can ask about recently our astronauts or the Indian Air Force pilot visited to the International Space Station using under which mission. You have to remember that it is under Axiom 4 mission. Okay. If you are listening this the classes that I am providing very carefully and revising once, there is high chances that you can directly answer all the question related to UPSC and state PCS. Okay. And before going, before making this doc, I have gone through all the important current affair that is available in the market. So I've added that and do some value addition. So no need to worry about it if you are watching it. So either you'll get it from here, otherwise, no student will able to find anywhere. ठीक है, चलिए आगे बढ़ते हैं. So profile India first. So Subhanshu Shukla is our first astronauts to visit international space stations, but second Indian in space after Rakesh Sharma. So I think you already know. राकेश शर्मा जी जो थे वो पहली इंडियंस थे जो मून पे गए थे अंडर विद द हेल्प ऑफ यूएसएसआर करंट रशिया. ठीक है. So next important question. So if space program is very important for our achieving Viksit Bharat, अगर हमें डेवलप इंडिया बनाना है, स्पेस प्रोग्राम अगर बहुत इंपॉर्टेंट है, then what kind of role space program is going to play? So first one is about the agriculture. I think you already know that in India around 50% of our population depends on agriculture, but it contributes hardly 15% to our GDP. So that is the reason our agriculture we need to develop. How we can develop? First, we are going to see what are the challenges that we are facing in this sector. For example, our agriculture is low productivity, erratic monsoon, and that is what led to the low productivity. So what is the space-based solution that we can provide in our agriculture? INSAT. So Indian satellite 3D we can install, 3DR resource set. So these things can be used to map water resource, map vegetation, map the agroclimate. We can map whether today is going to have rain, today is going to have a disaster like cyclone. We can predict better if we can provide advanced information about farmer that within next 3 days there will be rainfall. So farmer can plan accordingly, sowing, cutting of their plant. That is what led to the saving of their crop. Otherwise, that crop might destroy by this erratic climate. Okay. So next problem that we are facing in infrastructure, I think you all know that we are promising a lot of things in infrastructure. When it coming to the implementation, there is a huge delay. So because of this delay, so there is a time and cost overrun, and so challenges is planning this delay. So we can use this space technology to have integrated planning. We can monitor how our project are going on so that we can clear that. For example, if you are looking from the top, you can see how our slope is. We can design our infrastructure in a better way so that in a low cost we can find better quality of infrastructure. I think you already know about PM Gati Shakti use ISRO imagery for development of infrastructure. So this is the PM Gati Shakti. It is a technological platform that integrate 9 ministry. They use space-based technology to get infrastructure completion in faster way. Okay. Next one is about the disaster management. So I think you know already in Odisha during cyclone 1999. So 10,000 people are died in cyclone. I think 10,000 people are died in cyclone 1999. But same cyclone after 2019, after 20 years, hardly 29 people are died. Why this has happened? Because of we have improved our disaster management by using space-based application, like we are using weather radar, Doppler weather radar, then their communication. So that is what helpful in reducing mortality and wastage damage to our infrastructure also. So ISRO's DMS, disaster management support for real-time monitoring. So ISRO is providing real-time monitoring of all the disaster early warning. So that is what led to the safer evacuation, and we can save a lot of people. So next is about the security. So I think you all know we are having for example, if this is the India, so here we are having Bangladesh, here it is China, here it is Pakistan. All this terrain, it is passing through difficult terrain. For example, from desert, so our border area passing from the desert, from river, from snow peak mountain. So to monitor that, this border area 24 into 7, we need advanced technology that reduce our border, surveillance, and prevent the infiltration of all the terrorists. For that, what we are using radar satellite imaging, satellite, RIASAT full form is radar imaging satellite, and GSAT-7. So GSAT-7 is satellite dedicated for Indian Army. GSAT then 7A is dedicated for Air Force. GSAT-7B is dedicated for Navy. So whenever you are seeing any GSAT-7 or 7A or 7B, so they are dedicated for military operation. Okay. So next is Mission Shakti. So Mission Shakti, basically we are developing anti-satellite. For example, let's say this is the Earth and this is India. So if any satellite during war, let's say there is a enemy satellite is taking a lot of intelligence from India, we can take down by firing missile to that satellite. So that is what called Mission Shakti. It is an anti-satellite mission to destroy any satellite that is moving over Indian airspace. Okay. चलिए आगे बढ़ते हैं. So next is about autonomy. So I think you already know. So we cannot rely on USA and any other country during war. So they might not give this access. For example, during 1999 Kargil war, so USA is not ready to provide the GPS to India. That is what led to the India develop its own GPS, global positioning system. That is what called NavIC, or indigenous navigation. I think you already know all our missile, if they are firing from this locations to this location, what we need GPS. So for if we are relying on USA, so USA might mislead us. So instead of striking this location, this can be fall on different location. To make sure that our military operation are independent, we take independent operation, we need to develop our own GPS. That is what called NavIC, navigation with Indian constellation. So navigation with Indian constellation. It is a seven satellite in 8 steps. So there are 4 satellite here, 1 satellite here, 1 satellite, 2, 3, 4. So they revolve over the India, and 3 more satellite, they are in the geostationary orbit. Okay. So total is 7 satellite under the NavIC. So they are basically providing navigations to India and our neighbor country. Okay. चलिए आगे बढ़ते हैं. So next is environment. So in environment, we are seeing a lot of devastation, destruction we are facing, ranging from the deforestation, forest fire. So these are the challenges. So we can use NISAR, NASA, ISRO synthetic aperture radar will study the land, ice, and understand what are the changes that is happening on the surface of the earth. So you can see there are a lot of challenges we are facing, but there is a solution space technology can provide. So this can be very good question in your mains also. They can ask about how space technology helpful to solve the problem we are facing, or it can ask how space technology became a vehicle for achieving a developed India being India a developing country by 2047. You have to write all these point: agriculture, infrastructure, disaster management, security, and then these are challenges and these are solutions. Now, if you just make this table, this is more than enough to get good mark. Okay. And prelims also, they can ask about their application also. In healthcare, I think you already know remote sensing, telemedicine. For example, let's say there is an operation. Let's say there is an operation that is very important, need to be conducted in Arunachal Pradesh, but doctor is located in Gujarat. So in that case, we can operate through the telelink or telerobot through through that we can operate na. Or we can do, the doctor sitting at the Gandhinagar or Gujarat can guide doctor sitting at the Arunachal Pradesh how they can operate a critical surgery na. So that is what the helpful by the space based technology, because Arunachal Pradesh is not having that access to, let's say, the optical based internet. So there we need space based application. So next one is about the education. So I think you already know, far flung area of India, like northeast and the rural area, tribal area, they don't have proper internet. So we can use the satellite to deliver quality content na. So edusat for distance learning, I think you already know in our DTH. So lot of channel dedicated for education. So that is what led to the bridging the urban rural divides. So next is transparency. So welfare leakage. So I think you already know, there is a report by Rajiv Gandhi. 1 rupee spent by the government of India, only 36 paise reaching to the poor people. So that means there are a lot of wastage happening in the transmission from the government to people. So to curb that leakage or corruption, we need to geotagging each and every assets. For example, under Manrega, if we are creating a pond, if we are creating something infrastructure, we need to geotag, so that their detail will be mentioned and we can verify whether it is really that asset is created or not. So next is water management. So groundwater depletion. So I think you already know, India is having only 4% of global water, but that support 20% of the world population. So only 4% of the global water, but 20% of the population we need to support. For that, due to because of over dependency, only 4% of the water available, but India population is 20%. So because of this over reliance, our groundwater are depleting very fast, because we simply dig the very borewell and extract water without thinking about how we are going to recharge it. So to solve this, we are having Bhuvan Srishti Geo Portal. So that is what helpful for recharging of all this groundwater. So I think this is very important for your prelims and mains also. They can ask about how space technology is helpful for making India Viksit Bharat in the main. So prelims, they can ask about different thing. What are the role of space? Okay. So next, how progress in the space sector India, Bisobandhu. So how, if India is developing its space program, how it is helpful for all over the world. So I think you already know, there is a collaboration between India and USA for development of NISAR. What is the full form of NISAR? We are going to see that also. NASA ISRO Synthetic Aperture Radar as a global scientific handshake. So this program, both USA and NASA, US agencies, and India's ISRO agency, they collaborate to launch a satellite that can observe small changes on the Earth's surface. So that is helpful for disaster early warning also. So leadership role, India is launching South Asian satellite and NavIC for its neighbor. So if India is developing its space mission, it is not only benefit for India, but it is benefit to our neighbor also. For example, South Asian satellite is helpful to the South Asian nation. Our NavIC is helpful for neighbor country like Bangladesh, like Nepal, Bangladesh, Bhutan. So they can use it. So we are also sharing a lot of data that we are generating. For example, Chandrayaan 3 data we are providing on the Pradhan portal. Pradhan means giving it to everyone, and Unnati training. So whatever the data we are collecting in our space program, we are not making it secret. We are rather providing it open to everyone, so that India's growth journey will be helpful to everyone. So cost effectiveness, I think you already know, Mars orbiter mission. We have launched this Mars orbiter mission at the cost of 6 rupees per kilometer, which is less than your auto travel. So we have launched from India to Mars the satellite that is called Mars orbiter mission. What is the cost? It is 6 rupee per kilometer, which is less than your auto journey. If you're traveling in auto, the cost is very high. So you can see how frugal innovation ISRO is doing. So ISRO is already launching 400 satellite. We have already launched. So sustainability. So ISRO is planning to debris-free space mission by 2030. So I think you already know if this is R. So a lot of satellite we are launching each and every year. And when satellite end their lives, so they disintegrate to form space debris. So they are circulating around this space. So if this space debris collide with one another, so that is what led to the more space debris. So they might damage the entire space. So this is what called Kessler syndrome. This is called Kessler syndrome. That means, if there is a destruction of one satellite, that is create a lot of debris, and that debris with collide with one another create huge amount of debris entire satellite space, entire satellite would damage, and that is what converted into space debris. So India is planning to, remove all the space debris so that we can have space free of space debris by 2030. So we are exploring different way and methods to help that. Okay. So we are also adding in the international level for safety. For example, COSPAS and SATSAT membership. I think we are going to see it later on. So just have a patience. So what is it? So please remember, this can be a very good question. UPSC also. So recently we have seen government is taking a lot of policies to improve the space sector. For example, India space policy we have launched in 2023. So promote private sector participation in the space sector. So earlier space used to be exclusively domain of the government of India, but now we have opened up the space for the private sector. So FDI and startup ecosystem. So 100% FDI in space component over, and we are also having 300 startups. So government allowed 100% FDI in space sector, and already 300 startups are working in the space sector. So if there are success, so there might be, big space giant might emerge in future also from India. So framework, we have already launched New Space India Limited. This is the commercial arm. So because ISRO is developing a lot of technology, so we need to commercialize that. We need to market that. For that, we have developed NSIL, New Space India Limited. We have already launched in space. So this is what act as a facilitator. If private sector wanted to use ISRO's facility, they can help. They can, in space is going to help. So what is the full form of in space? India Space Authorization Center. Okay. So they help in development of, hand holding, support the private sector so that they can emerge as a giant. Okay. So definitely you can say space sector is going to play important role for helping India as a developed country. And we are planning to launch our Bharatiya Antrik Yan. That means India's space station. We need to have an Indian space station like International Space Station by 2035, and lunar mission. So maybe we are planning to have, human land on the moon, moon by 2040. ठीक है. So this can be a very good conclusion, mains also. चलिए आगे बढ़ते हैं. You can see about journey of ISRO. So starting from 1962 and 2025. So in 1962 we have formed INCOSPAR formed. So beginning a space journey. So here our scientists, they are carrying the rocket in a cycle. So you can see the image already available in Google. So in 1969 ISRO is established, official formation of the space agencies. But first satellite we have launched in 1975, name is Aryabhat. And 1980s, so our satellite launch vehicle 3 is successful. So we have launched Rohini series 1 placed in the orbit. So first satellite that is, indigenously, designed and launched from the India. So 2008 we are also achieve a milestone, first successful launching the Chandrayaan 1. So first lunar mission launched. In 2013 also we have created the history by Mars orbital mission, first Asian nations to reach Mars, and first nations to achieve success in first maiden mission. Okay. So in 2023 Chandrayaan 3, so we have successfully land on the moon, and 2025 action mission 4 Indian astronauts reached the International Space Station. You can see brief journey of ISRO. So you can also draw this diagram, examination if needed. So let's see about COSPAS SATSAT. So it's a global satellite system that detect and locate emergency distress beacon from the aircraft, SEAF, and hiker to facilitate rapid search and rescue. So the COSPAS SATSAT basically it track the distress signal and help them in their emergency. Okay. So parties, so founding members are USA, Russia, French, Canada, who manages the program. So space segment, country with having significant space satellite, they provide help. They are China, India, USA, okay, other country, and ground segment. So they are having ground-based radar to receive the signal. They are Australia, Brazil, Japan. So user states, they don't contribute anything, rather they are using it only. Okay. Just remember COSPAS SATSAT. What is it? So this can be a very good question in your UPSC also. चलिए आगे बढ़ते हैं. So next important topic that today we are going to discuss, India's first commercial Earth observation satellite Constellation. So this can be a very good question. Which space company recently owned the Earth observation satellite? Which country, which company is going to launch the Earth observation satellite also? So Pixel Space India led consortium own in space proposal for India's first fully indigenous commercial Earth observation satellite system. So we are going to have a constellation of Earth observation satellite system. So what is Earth observation? That means, there will be dedicated satellite that revolve around the Earth to monitor its resource, to monitor its, changes in the surface. It can be landform, it can be water, it can be environment, anything. Okay. So that is what we are planning. So this can be a very good question. Remember the pixel space. So more on the new, so consortium comprising of pure site space, Satur analytics, and Dhruva space. So the Earth observation PPP model. So private sector design, operate the Earth observation satellite system. Government provide the support. Government provide the support, but private sector they'll manage. So you can see how our private sector are maturing in the space sector. So funding, so 12,000 crore for private investment, and they reject the government proposals. So let's see about Earth observation satellite system that we are planning to have. What are the satellite numbers? So we are having 12 advanced Earth observation satellite over 5 years. So over 5 year we'll launch 12 para satellite हम launch करेंगे next 5 year में. So sensor, what kind of sensor will have? Panchromatic camera. So this camera will helpful for taking all multi, detailed picture. So multispectral. So that means, it will take picture in multi wavelength, hyperspectral. So dedicated image you can take. So next is SAR, synthetic aperture radar. So what kind of application we are going to have in Earth observation satellite? Just imagine in Earth observation satellite are launched very close to the Earth. Okay, very close to the Earth. So they will take a lot of photos, and these photos, the images are very helpful for understanding what climate monitoring, disaster management and agriculture, security, geospatial intelligence. So these are the application of Earth observation satellite system. So about Earth observation satellite. So called as Earth remote sensing satellite. So Earth observation. If you are observing our Earth, what kind of changes happening on the surface of the Earth, we can say these are Earth observation satellites. So they are also called as remote sensing satellite. They are designed to collect information about activities on the Earth, both natural and artificial, including physical, chemical, biological, and human system. So what kind of application we'll have? So Earth science, so related to Earth, like, rock system, water, so all these things, environment, wildlife. We can monitor the wildfire. We can monitor the tracking the movement of the wildlife also. It can helpful to track help during the disaster also. So significance of the private sector, yes, it will boost our economy if more private sector participate. Space economy is booming. It's 500 billion space economy, and in India is hardly we are contributing anything. So if our private sector contributes significantly, and our cost of launching is very less, so we can capture the international market. So if private sector participation also led to the innovation, na? So for example, the Firefly for hyperspectral images. So this technology might be having our civilian application also. So if our private sector focus all these launch vehicles, ISRO will focus on the deep space mission, like, missions to Mars, missions to, Venus. So outer planetary mission that ISRO can focus. So enable advanced mission for Antrix Bharat. So it will create job, yes, self-reliance. If we are having our own satellite system, we will not depend on all this, foreign country. So it will help in development of leadership. 300 startups strengthen global position from current 2% share. India is having only global 2% share. So it is helpful for become a global leader in space economy. So recently, government has taken a lot of steps. For example, in space, so Indian Space Promotion and Authorization Center 2020 Agency for Private Participation. So the in space help to handhold, support all these startup, all these newcomers, so that they can emerge as a giant later. So we have launched this space policy. Government is also supported through the 100 crore, 1000 crore startup funds. Then tech transport, ISRO is transferring the leading technology that is developing to industry partners. 100% FDI is allowed in the space sector. So challenges, there are a lot of challenges. For example, there is no dedicated legislations to define rules, laws, regulations. So that is what led to the legal ambiguity. Main challenges emerge in the future also. So operational regulatory delay due to multiple approvals. So I think you already know. So to get approval, we need multiple ministry. There is a bureaucratic delay. So that is what also hampering our space economy. Next, technology limited capacity of increasing import reliance. So no, we need high-end technology. I think you already know how Elon Musk company, they are developing, the space-based internet, advanced technology, reusable vehicles. So we need to also improve our technology. So demand. So upstream sector is nascent. So what is upstream? So if you are launching a satellite to this space, this is what called upstream. Once satellite is in space, So it will provide a lot of service to the customer. So this is called downstream. This is called upstream. This is called downstream. So in downstream, so we're already having a lot of market, but there is a lack of market for the upstream, lack of market for design, development, launch of satellite system and maintenance of the satellite system. So we need to correct all these things. ठीक है, चलिए आगे बढ़ते हैं. So this is very important. So recently NASA, that is NISAR satellite. So NASA ISRO synthetic aperture satellite successfully launched by ISRO. So NISAR satellite was successfully launched from the Satish Dhawan Space Center, Sriharikota, by our own ISRO. So about NISAR, so it's a joint venture between NASA and ISRO. So it used dual band, long band and short band micro imaging satellite, fully polarimetric and interferometric. That means it used dual band so that it can observe, just near ground and below ground, very clear image. Different frequency can penetrate ground at the different level. If it is short band, it can take the one level of images. If it is long band, it take image of different. So that is quite helpful for taking throughout image in all its time na. So what are NASA का contribution क्या है? L band radar, GPS, then telecom antenna. So NASA is contributing 1.16 billion, and what is ISRO is contributing? S-band radar, BOSS, and launch vehicle service that we are providing. So weight is 2.3 tons, and which orbit it is going to rotate? Sun synchronous polar orbit. Life cycle is 5 years. So dear student, this detail of the mission is very important. So they can ask about, NISAR is a single band microwave imaging satellite. No, it is dual band. So this can be a right, correct, wrong statement. So it can say this satellite is 4-ton class or 10-ton class. This is also wrong. So they can say this satellite will launch to polar satellite launch polar orbit. This is also wrong. It is going to launch to the sun synchronous orbit. So mission life, just remember, it is for 5 years. ठीक है, चलिए, you can see about NISAR satellite. So here it is given. So mission goal to understand earthquake, volcanic eruption, oil spill, flood, wildfire, landslide. ठीक है, you can just see and read it, you will understand better. So what are the objective of NISAR? So अगर हमने NISAR को लॉन्च किए तो क्या क्या वो जाके काम करेगा स्पेस पे? So measure the woody biomass and its change. So how our biomass is changing, it is going to observe. Track the change in the extent of active crop. How our cropping pattern are changing, it is going to observe that also. Understand changes in the wetland extent. So map Greenland and Antarctica ice sheet, dynamics of sea ice, mountain, glacier. Characterize land surface deformation related to seismicity, volcanism, landslide, subsidence, uplift associated with changes in the subsurface aquifer and hydrocarbon reservoir. So this is very important. So they can ask about what are the mission objective of NISAR. They can pick one or two statement. So it is going to helpful for understanding seismicity, like earthquake, even volcanism, landslide, even subsidence and uplift associated with all these changes. Okay, so please read it and understand it better. So either they can ask about detail about NISAR, like what are the technicality detail, or what are the mission objective of the NISAR. I think you'll get a question from here only. Please read it very carefully. If you just revise, you'll understand. So what are the technical feature of the NISAR? So it use SWAP SAR. What is SAR? Synthetic aperture radar for high resolution wide swath imaging. Swath means if a camera is moving, how wide image it is taking. Let's say it is taking image of 20 kilometer. This is what called swath of that radar. So high resolution image we can take by using SWAP SAR radar. So dual band synthetic aperture radar we are using. So it is L band and S band for vegetation, ice, soil, and canopy monitoring. So that is helpful for monitoring how our vegetation means, how greenery is changing, how ice is changing, how soil is changing. Okay. So 12 meter deployable antenna. So it is having a 12-meter antenna that can deploy in this space for communication. Open data policy for global access. So the data we are going to generate in our NISAR, it is open to everyone so that everyone can access it. So the next question is, what is synthetic aperture radar? So SAR is an active remote sensing technique, sending pulse and recording their reflection from the earth. That means if it is earth and our satellite will be here, so satellite will send a signal on the surface of the earth. So after it strike down, it will return, and by reading this signal it can observe or provide detail of it na. So SAR is an active means it is having its own source. For example, this is earth and this is the satellite. Okay, So it is having own source of energy, sending a signal, and it is bounced back. By reading this signal, it can tell about detail about this terrain. So remote sensing technique, sending pulse and recording their reflection from the earth. Unlike optical imagery, that is passive, because photo we are only taking passive image. Synthetic aperture radar interact with the terrain and vegetation, ice and soil moisture. So whenever you are doing active interaction, so that is what led to the better information about terrain na? So why we are using synthetic aperture radar? Higher spatial resolution required, impractically long antenna. Okay, so because of because high spatial resolution, so we need, so SARs combined with multiple acquisition from shutter antenna to stimulate a longer one, achieving high resolution image efficiently. So we can say we are using synthetic aperture radar to get high resolution image. Okay, no need to go all this technical detail. UPSC never ask all this technical detail, just have a basic idea about operation. So in my experience, they never ask, they don't expect the space engineer to be in clear the UPSC. They ask person having common idea who can understand it better. So understand the concept, no need to just ratification, no need to have ratification. Okay, चलिए आगे बढ़ते हैं. So Axiom 4 mission. So I think already Indian space astronaut landed on the International Space Station under the Axiom 4 mission. So it is very important. So they can ask about that also. Axiom 4 mission successfully returned July 15 in 2025. So Axiom 4 mission. So it's fourth private astronaut mission to the International Space Station by Axiom Space in collaboration with NASA and SpaceX. So this can be a very good question. So you have to remember Axiom 4 is a collaboration between NASA and SpaceX. So 14 days mission launch, aboarding SpaceX Dragon spacecraft via Falcon 9 launch from NASA Kennedy Space Center. So Falcon 9 is a reusable launch vehicle. So just remember, and Subhanshu Shukla ji, I think you need to remember the name also. Subhanshu Shukla is the first Indian to land on the International Space Station, second Indian to travel the space after Rakesh Sharma. So what are the aims of these missions? To realize the return to the human space flight for India, Poland and Hungary. So during this mission, our ISRO conducted a lot of studies in the International Space Station. So what are that? Crop growth in this space. We have observed how crops are growing in this space. Cyanobacteria for life support. I think you already know brewed in algae. They are called cyanobacteria. If cyanobacteria can be cultivated in this space, so they help in generating oxygen. So that is can support our life. Na? So space microalgae as a fuel and food. So we can grow microalgae in this space, so that can provide food and fuel to our astronauts. Na? Then mycogenesis and muscle loss. So we have already said some tardigrade to so see their resilience. So cognitive impact of screen use and STEM outreach. So I think this mission objective, or we have conducted some studies, so you have to remember it. So this can be a very good question. So how the mission is significance for India? Support Gaganyaan mission. Na? Whatever we have learned, whatever experience we are having in this journey, so that can be helpful for our own launching our own Gaganyaan mission. Na? So boost global partnership and space diplomacy. Yes, so that is what helpful to develop good relations with other countries. Stimulate India private sector. Na? So this success also motivate the private sector to participate in the space sector. So inspire youth in the STEM field. What is the full form of STEM? Science, technology, engineering, and mathematics. So what are the challenges? Technology. So if you launch International Space Station, you need a lot of technology. For example, in outer space there is no oxygen, so we need life support system. And outer space, lot of radiation is there, so we need to have radiation shielding. So during re-entry, so whenever the satellite, the module is entering into our space, so there will be a lot of friction. So because of that, there might be fire. So we need to have a re-entry protection and launch safety. So in case, let's say during launching, if there is a fire, so we need to abort that, and we need to ensure that our astronauts are safely landed. Na? So these are challenges we need to overcome. So logistical challenges like high cost, rigorous astronauts training is required, because to send someone in this space, microgravity condition where everything is floating. So what we need to have person with high level of training and motivations. Okay, so let's see something about International Space Station. This can be a very good question also. They can ask about consider the following statement regarding International Space Station, and followed by truthful statement. So it is a habitable satellite in low earth orbit. It is in low earth orbit, LEO. So International Space Station located in low earth orbit, 370 to 460 kilometer, orbiting earth in every 90 minutes at a speed of 28,000 kilometers per hour. So partner is NASA, ISRO, NASA, Russia, European Space Agency, JAXA, Japan, CSA, Canada. So you can see about it is a collaboration of NASA, Russia, Cosmos, Roscosmos, European Space Agencies, even JAXA, Japanese Space Agencies, and Canada Space Agencies. So largest space laboratory. So it is the largest space laboratory that we have launched, covering 90% of inhabited Earth. So first launch in 1998, operational till 2030. It will operate till 2030. So about Gaganyaan program. So if you just read it, so India's first human flight mission approved in 2018. So aim to demonstrate human space flight capability by launching a crew. So our Gaganyaan program is basically aimed to launch human into space and develop our capability. Okay, so we are going to launch vehicle module 3, launch vehicle. There will be orbiter module, there will be crew and service module, so extended to include Bharatiya Antariksh Station. So we are planning to launch our astronauts into space. So they will stay there for 5 to 7 days. 2 to 3 astronauts, they will live there and will do a lot of study there. So it will having, we'll launch through a launch vehicle 3, and there will be orbiter module that orbit around the Earth. And that orbital module include one is service module and crew module. Crew module is actually house where our astronauts will stay, and service module provide all the support system that is needed in the crew module. Okay, so whatever learning we'll have in this Gaganyaan mission is going to helpful for our Bharatiya Antariksh Yan. So about Bharatiya Antariksh Yan or space station, planned Indian space station 400 to 450 kilometer with 5 modules. So if you are launching a big space station in this international space station at the space, will break down that big into small 5 component, and at one component will launch once, and second component through the second satellite, third satellite, fourth vehicle, and then will assemble in this space. Instead of sending big satellite like 20, 40, 50 tons into space is near to impossible. We can launch small component like 4 ton 5 ton, and then we'll assemble everything in the space. We have already conducted space docking experiment. It's called space dex experiment. So if 2 satellites are there, they can locked in the international in the space, and then that is what going to connect the individual pieces. Okay, so this is what about all about our future Gaganyaan mission, International Space Station, and recently successful returning of our astronauts Subhanshu Shukla from in the Axiom 4 mission. So let's see next important topic that we are going to see, black hole merger. So I think you already know black hole. There is a lot of curiosity at the international level to study about the black holes. So recent there is observed that 2 black hole merge. So an international network of gravitational wave observatory detect a merger of 2 massive black holes. So you can see black holes are high density particles, after a big star lost all its energy, so it can collapse. All material are condensed in a very small size from the core, and because of this huge mass of that black hole, it attract everything towards it. Even the light cannot escape from it. So that is the reason it is very difficult to study the black holes. So if you are sending some signal to, you want a reflect back to study the shape of the black hole, but black hole is absorbing everything, it is not giving any reflection, then we are having no idea about what is the shape of black hole. Whatever coming signal, whatever material it is coming near to it, it is absorbing everything. So that is what led to the challenges in observing the black holes. So more about the news. So 140 and 100 solar masses merge. So largest observed merger. So that the 2 big star that is merging to form the black hole, having the size 140 times the solar mass. 140 गुना बड़ा है solar system our sun से, and 100 times bigger than our sun. Just imagine how massive they are. So the event name is uh, GW231123. Just remember, they can ask about GW231123 recently seen in news related to what. Just imagine GW23. There is a pattern. If you are just observing once, you can also take it. So occurring a billions of year ago. So this is occurred a billions of year ago. If it is happening a long distance and it is traveling in the space billions of kilometers, and we are observing here. So that means to a signal reach from here to here, it will take billion of years. So now we are observing the signal, but the event is happened billions of years ago. Okay, so what significance it is providing, or what are the helpful, it is helpful for our understanding. So refine astrophysical and cosmological, so help update model of black holes formations, then stellar evolution, gravity, cosmology, and particle physics. So challenging the black hole formation. So largest and fastest spinning black holes detect, suggesting complex formation history. So hierarchical merger insight. So gravitational wave as a tool. Okay. So I don't think no need to go all these technical details, because they're not going to ask all these details. So they can ask about basic things. Okay. So to detect all this gravitational waves, so already we are having lot of LIGO. What is the full form of LIGO? Laser Interferometer Gravitational Observatory. So we are going to see it. So LIGO in USA, largest observatory to detection, it's Sanford and Livingstone. So LIGO India is also planning to have our LIGO in Hingoli district of Maharashtra, with the Department of Atomic Energy, DST, and USA agencies collaboration. So already we are having Virgo. So it is in Italy by European Gravitational Observatory, Italy and France, and Kagra at Japan, located inside the Kamikoa mines. So you can see about the laser interferometer. So here, from here, we are sending a laser signal. It will go here, and there will be mirror and bounce back. Now, if there is no disturbances, so the signal will bounce back. Then here also signal is bounce back, and total is cancel out. So net effect is zero. But while signal is traveling and back, if there is a ripple in this space time, so this balance will be disbalanced. So that is what led to the signal will not cancel out. So that is helpful for observation of the you can say gravitational wave. Dekho, whenever two black holes they are spinning, so that is what creating a ripple in the space. Na? So this ripple in space will make up and down, just like the water surface of the water. If there is a wave, or you can just throw a stone on the surface of the, आप जब पानी में एक पत्थर फेंकोगे क्या होगा, पानी ऊपर नीचे होगा, उस समय जो भी रहेगा सबका डिस्टर्बेंसेस हो जाएगा. So same thing happen in this space. Whenever two objects are rotating very fast, so they are making space vibration, and this wave is called gravitational wave. Okay, so gravitational wave is observed by using LIGO, Laser Interferometer Gravitational Observatory. So next is about the black hole. So what is a black hole? So black hole region in this space with gravity so strong that even light cannot escape. मैंने ऑलरेडी बताया कि ये जो ब्लैक होल्स के अंदर इतने हाई मासेस होती है, it is attracting everything towards it. Even whenever you are sending some light signal to get some insight about ब्लैक होल, हमें ब्लैक होल के बारे में स्टडी के लिए लाइट सिग्नल सेंड करें, कभी भी वो लाइट सिग्नल को ऑब्जर्व करके देता है, कुछ रिटर्न नहीं होता है. सो दैट इज द रीजन वी डोंट हैव एनी आइडिया अबाउट ब्लैक होल्स ना. So a region in this space with gravity so strong that even light cannot escape, formed by a matter compressed into tiny space. So all this matter, they are compressed to tiny space. Because of that, it is having heavy mass, and heavy mass led to the high gravity. So it is not letting anything come out. So detection invisible to the telescope. So study via effect on the nearby star and gases. So black hole is not visible by the telescope, because telescope is sending some signal, or we are observing some light, but black hole is absorbing everything. It is not letting anything to go. So if it is not emitting anything, it's very difficult for telescope to understand. Na? So formation. So most form from the massive star core collapse after supernova. Supernova means blasting of its core, and smaller core may become neutron star. That means star without having any energy. So this is about the black holes. So black holes are so massive that having huge gravitational force that is not let anything to come out of it. So that is the reason it's very difficult for studying the black holes. So dear student, this is all about the first class of science and technology. So we are going to have one more class. So there I'll discuss about some other news. So dear student, if you like this video, please like, subscribe to my channel. Please do share this video with your friends, so that more number of students can benefit. And dear student, please write your thought in the comment box, so that your feedback is very important for improving this class. So I'm not seeing your face. It's very difficult for me to understand whether you are getting it or not. So through your feedback, I'm able to understand what's going on and what kind of problem you are facing. So please make this class interactive and give feedback. Chaliye dear student, we'll have to end here. Bye bye. Take care.